The first thing we have to do is download. Download something to animate. It's possible to build our own parts. However, when designing and building robots, we are usually using manufactured items that have already been designed and exist in digital form, like screws, bolts, washers, nuts, metal strips, wires, motors, etc. One of the most basic concepts of digital design since the internet began is the free sharing of digital images. And this is still a major part of FRC, with Chief Delphi as one of the central sites. MK North America Inc. is one of the major commercial suppliers of parts to FRC. And they've made a widget you can install on your Onshape workspace that makes it very easy to download images of their products. You can see they have bearings. They have electronics. They have gears. All kinds of things that you can use to build robots. Swerve drives have interested me since I first encountered them. And they're especially interesting to animate because they have several moving components that involve different kinds and sizes of gears that interact with each other. Swerve drives have been around for a long time. However, they've not actually been used much in competition until this last year. The reason is because of the complexity of programming them and the lack of a mass-produced version, which MK has now solved. I began by animating the mk4i Swerve Drive and then moved on to the mk4i, which is a little more complex. So to illustrate how to animate them, we can just take what we need from my Onshape portfolio. Here we are with an empty document. The first thing I'm going to do is knock out this part studio. I'm only going to download assemblies, and I don't want to accidentally shove something into a part studio and later spend an hour looking for it because it's not where I expect it to be. And next I'm going to go up here, left click on insert. I don't want the current document because there's nothing in it. I don't want the standard content document because it's full of stuff I don't need. What I need is other documents. Okay, and these are mine. And so I look here. There's my Onshape recently opened, created by me, shared with me in public documents. Okay, this would be like Chief Delphi. Okay, so my Onshape, and I do want Swerve Drive 4, and when I get there, I want assemblies. Okay, and the assembly I want is the mk4 wheel assembly. So I click on that just once, because if I click on it 10 times, I get 10 of these. And I only want one. Okay, and I just drag it out here and click on it, and it will stay right there until I do something. So right now I'm going to flip this thing, and there it is. It looks pretty good. This wheel is the most important part of the whole assembly. It turns and it goes around. I want to show you what all is involved in this piece right here. Here's what we have so far. Assembly 1's the main assembly for this document. Now the origin is not something that's usually important in assemblies, and so I just hide it. So I don't think it's a part floating out there all by itself. And the wheel assembly is our first subassembly. Since it's been imported from another document, it does not have a tab at the bottom of the document. It does have a linked symbol in the feature list, and if you click on it, you get this reference manager menu, and it tells you, in this case, the newer versions are available for 0 documents. So we don't really have to do anything, but if there were changes, then we have the option of updating the part. Okay, when you click on the arrow pointer, the feature list for the wheel assembly drops down. In this assembly there are 19 instances, and they are all parts. Later I'll show you an assembly that has a subassembly in the feature list. The parts in this feature list cannot be modified in this assembly. However, there are several things that you can do. For example, if you click on a part like this screw, then you'll see it highlighted over in the parts, well, in the feature list. And if you mouse over it like this, you get the whole name for this part, which is actually in itself a description of the part, and it also has the MK part number. So if you wanted to order the part, you can do that. And it also tells you that this is a 5th part in the list. Now you can right click on the part either in the workspace or in the feature list, and you get exactly the same list. These are the different things that you can do. Now, if you decide that you want to modify a part, then you hit this edit in context, and it is going to take you to the part studio in the document where you imported that. However, it does not highlight the feature you're looking for, so you have to know which one it is, and then you can click on it, or actually you want to right click on it, and it tells you what you can do with that part, which is not much. You can assign a material, you can edit the appearance. One more thing I want to show you here, and it says for mate features and it says group. Okay, I'm going to click on this here so that we can get that menu up, and we can look on that instant list and see that every instance in this assembly is in this one group. Okay, and the reason for that is that the group uses the least amount of information to hold an assembly together. But when we go to move something that's in a group like this, well, let's do that. You move the whole group, and it doesn't matter which part I select. You can see that it's going to move. And the other thing is, and this is both irritating but really good, if you click on this and you go to delete this, you can do that. Okay, and if we want to change something about it, we can take it out of the group and make those changes. Next, I need the assembly that connects to this wheel. So I go up here and click on Insert, and then I click on Other Documents, and my Onshape. I am using this one, I believe. Assemblies, and I want the pulley assembly. And I click on that just once. Okay, this wheel has to go on this axle, which is actually a shoulder screw. And this is a spacer that will hold the wheel on the axle at the right distance. Okay, but these two things are both in the way of putting in the revolute, so I'm going to hide them. Okay, now this large black thing is a bevel gear, and it has to go where the drive shaft will be able to connect with it. Okay, now these are wheel mounts, and this wheel mount over here has a slot in it, and that's where the drive shaft goes. So I am going to select a revolute. Okay, now we have to have two mate connectors. Actually, these are halves of mate connectors. And the first one is I'm going to put on this mount right here. Now that's a hole, so there's 3 places where you can get it, and I want it just to be on the surface right here. Okay, and I am going to connect it with this hole here in this bearing. You can see this did not go between the wheel mounts. However, if I flip the primary axis on this, you will see that it is now lined up against this mount. Now we're going to test it. And first we have to OK this. Now we right click on this, and we go down the list here, and we see Animate. Okay. Now it's going to start at 0 degrees, and it's going to go 360 degrees in 300 steps. Okay, so it's going to make a complete revolution. And then it's going to go back because this is reciprocate. Okay, now we could actually have it go 360 degrees and stop, or we could have it just keep on going and going if we clicked on loop. Okay, so anyway, we're going to do reciprocate. Just to me, it's kind of interesting. Now, the 300 steps, if we want it to go faster, we use less steps. If we want it to go slower, we use more steps. Okay, and I'm just going to use the 300 steps. It's a fairly decent thing. Okay, so now it's kind of interesting because instead of the wheel going around, we've got the motor mount going around. But that's all right. It doesn't really matter. Now, there is something, however, that does matter. And that is right there. You can see this motor mount is going through this bevel gear. And we do not want that. However, in Onshape, you cannot make parts solid. In other programs, for example, Blender, you can make parts solid and they will not intersect. In fact, in Blender, you can get them to bounce off of each other. So anyway, that's not happening here. Okay, so what we've got here is called interference. Okay, so I am going to stop this. Now you can see there that this is way too close. So actually I want to do a couple things. I've got a couple things hidden that don't need to be hidden anymore. And they're here in the pulley assembly. Okay, one of them is that shoulder screw, and the other one is the spacer. Okay, so those things are back. Okay, now our problem is to move this wheel mount and this. Well, let's do this. Need that wheel mount and that bevel gear to not be intersecting. The first thing I'm going to do is show you here, check interference. Okay, now you can see, if you couldn't see before, where the interference is occurring. And it's the motor mount and the bevel gear. So we have to move the motor mount and the bearing apart. So we're going to close this off, and we are going to go down here, and there is the revolute, and so we're going to pop up the menu for that, and I'm going to turn this just a little bit so we can kind of watch what happens. And what we're going to do is called offset. Okay, now if we get it here, you can see that this is the z-axis. The green is the y-axis and the red is the x-axis. Okay, we're actually going to move it on the z-axis. So right here, it's at 0, so it's not offset. When you highlight it like this, and you're on a PC like I am, you can just roll that middle mouse button, and it gets this thing to move. Okay, in fact, that looks like it moved in the right direction. Because if I went the other direction, yeah. Okay, so back here, I need a little space. What do we got here? 2/10. Okay, so let's try that. Let's click on the motor mount, click on the bevel gear, and then we're going to check for interference. And it says no interference. And we've got the bevel gear and the wheel mount and the bearing, and there's no interference. Okay. Now, let's see, over on this side. Okay, this side is obviously clear too. So, that's going to work for us, I think. There's no interference. Let's give it a shot, see what it looks like. Okay, if we look here, we can see that it's going around and it is not intersecting. Okay. I am going to bring in the structural assembly now. This structural assembly holds all these other sub-assemblies together in the structure. And this structure is also what connects to the rest of the robot. I am going to fix this structure, and fix means that I'm going to make it so that it cannot move. And I am going to go down here, grab this plate, right click on it, and hit fix. Okay, so everything is going to be eventually attached to this, to the structure. And to make it easier, I'm going to flip it on its bottom. Okay, I'm going to take a revolute. Okay, now at this point you might think I've screwed up because this thing is sitting out here all by itself. But when I do this, it jumps right into place. Okay, let's take a look here. Looks pretty good. Let's see, anything that's in the way of anything else? Okay, so let's go down here and see what it looks like when it's moving. Okay, so that's how you steer it. I am going to bring in the drive shaft assembly. Okay, documents, assemblies. Yeah, I don't know why I call it drive wheel assembly, but that's what it is. Now, this bevel gear has to go right there. This gear has to go right there. Okay, so I am going to do a little manipulation here. I want to turn this thing over. And I want to hide a couple of pieces because they're going to be in the way. And then I'm going to hide this one too. Come on, hide. Do a revolute. Right there. And we're going to do right there. Okay. Now, okay. Now, it looks like it should. Let's take a look and see what it looks like when it's moving. Okay, looks like it's doing what it should do. I have finished the assembly. There's now 9 instances. One of those is a group, and the rest of them are assemblies or sub-assemblies. Each sub-assembly is held together by a group. Okay. And if you want to see the group, you do that, and there are all the pieces that have been included in that group, which in this case is all of them in a subassembly. Now, if you want to modify the group, or if you want to modify a sub-assembly or a part, you're going to have to go back to the linked document in the place where you got your parts, your assemblies. Okay, the next thing that we need to do is make it possible so that we can animate all of the mates at the same time, or part of the mates at the same time. Now I really like to have the drivetrain separate from the steering train. So anyway, that's the next thing that we're going to do, is show you how to chain these mate connectors together. I have rearranged the Revolute mates and renamed them to identify the sub-assembly that will move when the Revolute is animated. In addition, I've added gear relations that chain the gears together. To get to the API, you left click on the two gears at the top, and there it is. Here's the gear relation between the drive motor and the drive idler. The gear on the drive motor has 14 teeth, and the idler has 50 teeth. You always divide the smaller number by the bigger number, so the relation is always 1 or less. In this case, 14 divided by 50 is 0.28. After you enter that relationship, test to see if the gears are meshing correctly. You run the test by animating one of the revolutes. Okay, in this case, you can see that the teeth are clashing. So we're going to change that. So we go back over here and unreverse the direction. And then we test that again. Okay, you can see that the teeth are meshing, and so this is working. I wanted to show you just two gears working together. To do that, I suppressed a couple of relationships. Now I'm going to show you how to make chains of relationships. Right now I'm going to unsuppress this relationship. Okay, and I'm just going to animate this one. Okay, now this is the drivetrain. There's the drive motor, and it drives this idler, and that drives this double gear, and that double gear comes into the drive shaft right there, drives that drive shaft, and then that drives the wheel around. Okay, now I'm going to just run one of these. Okay, here's the steering motor. And this is the gear that is attached to a shaft that goes down and drives the belt. And the belt turns the pulley. And that's how you drive it. Now, I'm going to go down here and unsuppress this. Now all the gears are hooked together, and so I'm just going to animate one of these after I get rid of that thing. Go away. Okay, now we can see the whole thing.